travel beyond the stars and unlock the mysteries of the universe.
Have you ever considered that the universe might just end? Not with a bang, not with a whimper, but with a quiet, systematic deletion. The culprit, a black hole. But physics tells us it isn't. The information is just scrambled, transformed into smoke, ash, and heat. In theory, if you could track every single particle, you could reconstruct the book. Now, imagine throwing that same book into a black hole. According to Einstein's theory of general relativity, the book, and all the information it contains, crosses the event horizon, a point of no return, and is crushed into the singularity at the center. It's gone, forever sealed off from our universe. This doesn't seem like a big problem, right? The information is just somewhere else. Over an unimaginably long time, this leakage causes the black hole to shrink and eventually evaporate completely, leaving behind nothing but a faint glow of random thermal energy. And here lies the paradox, the great cosmic conundrum. If the black hole evaporates, what happens to the information from the book we threw in? It can't be in the Hawking radiation, because that radiation is supposed to be completely random, thermal, carrying no specific information. It has simply vanished. This violates one of the most sacred principles of quantum mechanics, the conservation of information. Physics, as we know it, breaks down. This isn't just an academic debate. If information can truly be destroyed, then the link between past and future is severed. We couldn't be certain that the universe evolves in a predictable, logical way, the very fabric of causality. The idea that every effect has a cause would be thrown into question. It's like discovering the universe has a delete button and black holes are pressing it. For decades, physicists have wrestled with this. Hawking himself was convinced information was lost, a stance that sent shockwaves through the scientific community. It sparked what's known as the Black Hole Wars, a friendly but fierce intellectual battle between Hawking and other giants of physics like Gerard T. Hooft and Leonard Su. They argued that information had to be preserved, no matter what. So, where could the information go? This is where the story shifts from established physics to the wild frontiers of esoteric analysis and speculation. One of the most prominent ideas is the holographic principle, championed by Susskind and T. Hooft. This theory suggests that all the information that falls into a black hole isn't actually lost inside. Instead, it gets imprinted, encoded onto the two-dimensional surface of the event horizon like a hologram. Think of a credit card. The three-dimensional information about your account is stored on a two-dimensional magnetic strip. The holographic principle scales this up to a cosmic level. Our seemingly three-dimensional reality might just be a projection of information stored on a distant two-dimensional surface. This idea leads to even more profound, almost mystical implications. If a black hole, an object of immense gravity and density, can be described by a 2D surface, could our entire universe be a hologram? Could our perceptions of depth, space, and time be an illusion projected from a lower dimensional boundary at the edge of the cosmos? It's a concept that blurs the line between physics and philosophy, suggesting that reality is fundamentally about information. We are not just matter and energy. We are patterns of information playing out on a cosmic screen. Another mind-bending proposal is the idea of firewalls. A few years ago, a group of physicists suggested that to preserve information, something violent must happen at the event horizon. They proposed a firewall, a high-energy wall of particles that would incinerate anything attempting to cross it. If you fell toward a black hole, you wouldn't slide gently past the event horizon. You would be instantly burned to a crisp. In this scenario, the information from our book never actually enters the black hole. It's stopped at the border, and its information is immediately radiated back out. The problem? This directly contradicts Einstein's theory of general relativity, which states that an observer falling into a black hole shouldn't notice anything special as they cross the event horizon. Our universe might be just one of an infinite number, each born from the singularity of a black hole in a parent universe. Or maybe the information is stored in what are called remnants. It could shrink down to a tiny, plunk-sized nugget that contains all the information it ever swallowed. These remnants would be stable, dotting the universe like cosmic hard drives, holding the lost libraries of everything that ever fell into a black hole. But this idea has its own problems. It would mean the universe is filled with an enormous number of these unobservable particles, which should have detectable gravitational effects that we just don't see. Even Stephen Hawking eventually changed his mind. In 2004, he famously conceded the bet he made, admitting that information is likely not lost. His newer theories suggested that information is stored in distortions on the event horizon, what he called soft hair. These are zero-energy particles that surround the black hole, creating an imprint of everything that falls in. When the black hole evaporates, this soft hair imprints its information onto the outgoing radiation. So, where does that leave us? Standing at the edge of human knowledge, peering into an abyss of uncertainty. The information paradox isn't just a riddle about black holes. It's a signpost pointing toward a deeper theory of reality. a theory of quantum gravity that will finally unite Einstein's relativity with the strange world of quantum mechanics. The answer could rewrite everything we think we know about space, time, and existence itself. Is our universe a hologram? Are there infinite other universes connected by black hole wormholes? Or is there a fundamental law of physics we have yet to even imagine? The paradox remains. The universe may not be getting deleted, but it is certainly being rewritten. What do you think? Is information truly lost? Or is it hidden in ways we can't yet comprehend? Let me know your theories in the comments below. If you found this journey into the unknown as fascinating as I do, please hit that like button, share this video with a friend, and subscribe for more explorations into the mysteries of the cosmos. Thanks for watching.